Welcome folks. In this video we are going to look at some formulas that are used in more concept. So first begin by focusing on the formulas that we can use to find the number of moles. So the first one, and before we look at that, what determines the formula to be used is the data that you are given. So pay attention to the data, then you'll be able to choose the formula that is applicable for that data. So the first one is number of moles is equal to x over Na. So where small letter n represents number of moles, then for x, these can be number of ions, molecules, or atoms. Or we can simplify this by saying the x represents the basic units of matter. So if the question asks you to find ions, molecules, or atoms, it simply means you are solving for x. Now what if we want to make x the subject of formula? So we know it's over 1, so this will give us ions, molecules, atoms can be calculated by multiplying number of moles multiplied by the Avogadro's constant. So the Na is the Avogadro's constant. So this number is 6.02 times 10 raised to the power 23. Then the second formula that we can use to find the number of moles is when you are given mass. So whenever you are given mass, its number of moles is equal to mass divided by the molar mass, where mass should be in grams. So in case you are given in kilograms, don't forget to change. Then for molar mass, you just have to calculate using the periodic table. For example, if I want the molar mass for water, first I need to look at the chemical formula for water. Then first I will begin by relative molecular. So we'll say hydrogen multiplied by the number of atoms plus oxygen multiplied by the number of atoms. So the mass number for hydrogen is 1 times 2 plus 16 times 1. Then the sum of these two numbers is 18. So 18 is the relative molecular mass. Now what of the molar mass? So the molar mass is, now you just add grams per mole. So whenever you see grams per mole, that's a molar mass. Now in case where you are given a number of moles and you want to find a mass, so how can we find mass? So mass is equal to number of moles multiplied by molar mass. Now sometimes you may be given questions like you are given ions or molecules, and you are told to find the mass, and you don't want to find each separately, you want to find it at once. So we can say M is equal to, we know that N can be substituted with this part here. So we can have X divided by Na multiplied by molar mass. So which is mass is equal to molar mass multiplied by X over Avogadro's constant. Right, so we move on to the third formula for number of moles. So say number of moles is equal to volume divided by molar volume. So for this one, you need to know and remember that you only use this formula if you are dealing with a gas, and the condition is also stated in the question. So the V is the volume of the gas, and should be in decimeter cubed. So if given in centimeter cubed, don't forget to convert. Then MV or Vm, this is the molar volume. For this one, it's given under the condition. So if the condition is STP, then Vm is equal to 22.4 decimeter cubed. If the condition is RTP, then VM is 24 decimeter cubed. Then what if we want to find the number of moles? So if we want to find the number of moles, the volume, its volume is equal to number of moles multiplied by molar volume. So it depends on the data that you have. And with the previous formula that you've looked at, you can get the any formula and also insert by this number of moles if the data allows that. Then if we move on from this, then the other formula that we can look at is number of moles is equal to concentration multiplied by volume. So where concentration should be in moles per decimeter cubed, then for volume it should be in decimeter cubed. Then we know the units for number of moles. So what if we want concentration? If we want concentration, the formula is concentration is equal to the number of moles of the solute divided by the volume of the solution. So this is our formula. Now we also have to look at dilution. So dilution is just the addition of water to a concentrated solution to make it less concentration. Now the key point is the number of moles, we say before dilution is equal to number of moles after dilution. We'll consider the left side as the initial, then the right side as our final. So the right side represents when the solution has been diluted. So now if we go back to the formula where we are dealing with concentration, we know that number of moles is equal to concentration times volume. So since we are saying that the number of moles before and after dilution remains the same, then where there is N we can put CV. So we'll say Ci times VI, which represents or tells us that the concentration from the initial multiplied by the volume from the initial must be equal to the concentration from the final times the volume from the final. So this is the formula that you are supposed to use whenever you are dealing with dilution. Then if you look at the relationship between concentration and volume, these two are inversely related, which means that if you increase the volume, then the concentration decreases. Then the reverse is also true. Then from this formula we have the Avogadro's law where we deal with gases. And for these questions, the condition is make sure that you are dealing with a balanced chemical. So whenever you mess up balancing, then the calculations also becomes an issue. So the formula is volume 1, which is the initial volume, over number of moles for the first party must be equal to V2 over N2. Now, how can we apply this formula? So let me see if I can give you an example. So we can say if 500 cubic, so we have 500 cubic centimeters of let's say nitrogen gas is reacted with hydrogen, then the product is ammonia. Now if the question is find let's say the volume of ammonia produced, so our first step is we need to write a balanced chemical equation. So say we have nitrogen diatomic plus hydrogen also diatomic, then we have the product ammonia NH3. So we have to make sure that this equation is balanced. So let's put 2 here. So we have 2 atoms of nitrogen on both sides, but 6 atoms of hydrogen on the right side. So we need to put a 3 here. Now this equation is balanced. Now the volume that we are given is for nitrogen, so 500 cubic centimeters is for nitrogen. Then the question is, we want this. So how can we use this formula? We can now say V1, so the first volume over N1 is equal to V2 over N2. So the N can represent the mole ratio or the number of moles if you have the number of moles. So let's put this. So we say the volume for the first given volume is 500 cubic centimeters over, then the number of moles we are not given, but we use the mole ratio. So the mole ratio for nitrogen is 1, so over 1 is equal to, we want V2, the volume for the second gas, so we just put V2 over, the mole ratio for ammonia is 2, so we put 2, then we cross multiply. 1 times V will give us V2, then 500 multiplied by 2 will give us 1000 cubic of ammonia will be produced. So I just wanted to give you the concept of how this formula can be applied. Then we also have the formula for percentage yield. So percentage yield is, we need the actual yield, then divided by theoretical yield, then multiply by 100%. Now for this one, actual yield is the amount of the products that you get after the experiment is done. So the actual, for example, let's say you have flour, then you want to make some, let's say you want to do some baking, and you expect to have, maybe let's say you are expecting to have maybe 1,000 of for example fritters. Then after the actual preparation is done, only to find out that you get 800. So the 800 is what you expected. So this is, 800 is what you have gotten. So this is the actual. Then 1000 is what you expected, maybe based on the calculations. So this is the theoretical. So for this formula, the theoretical is based on the calculations, then the actual is the one that you've gotten. So this is what you, then if you are looking at the percentage purity, the formula still remains the same. It's actual yield over theoretical, but this time you have to look into this based on the purity. Then there are also other questions that requires you to maybe balance the chemical equation. For example, mass to mass, then mole to moles. We also have a limiting reagent where you want to determine the reactant that will be used up first before the other one is done. So on that one, it just involves finding the number of moles. Then you compare. Then the last formula that we are going to use is where you are dealing with titration, the reaction between strong acids and strong bases, where we have number of moles of acids divided by number of moles of bases is equal to concentration of an acid multiplied by volume of an acid over concentration of a base times the volume of a base. So these are the most formula that we can use. So this is what I wanted to share with you. And if you want more examples of or more concept questions, you can just search. I have videos that covers these questions. You can just search under my channel. You'll be able to find them. So that's it for this video. Thanks for watching.